Hi, we start with sessions now on polynomials. I've already written that on the left hand corner of the screen that informs us of the topic. You must have learned what is a polynomial, but herein I'm just discussing what is the degree related to the degree of polynomial. How do we name them? What is the degree of the polynomial? I tell you that is the highest power of the x in any polynomial given. Suppose I've given any polynomial which is represented as px. The degree, the maximum power of x. Suppose I take up, I'm just writing few polynomials. This minus 4x plus 2, or I'm writing simply x squared plus 2x minus 1. Or simply I'm writing 2x plus 6. In these three polynomials here, if you see, x has got the power which is 1. The power of x is 1. That's the maximum power of x here. So that makes this linear polynomial. That means whose maximum power of x is 1. If you look at this part, the maximum power of x is 2 because here x is 1. So this is a polynomial with maximum power 2, which is called a quadratic polynomial. Then comes the cubic polynomial, the polynomial with power 3. This is cubic polynomial. So by the degree of the polynomial, I have segregated the names of the polynomials as cubic, quadratic and linear. Now what is the value of a px? How do we define actually the zero of a polynomial? Suppose there is any px is represented by any polynomial expression, that is maybe any of them. I take this example wherein it is x square minus 3x minus 4. This is a polynomial. Now if I replace this x with any number, any integer, like if I might just try with x being 0, x might be equal to minus 1, 2 and 4. Now I'll replace x as 0 in the first go. So what do my polynomial give the value? It is 0 square minus 3 into 0. I'm simply replacing x with 0 first. That's giving an answer 0 minus 0, so it is minus 4. If I am replacing it with a minus 1, I'm getting minus 1 square minus 3 into minus 1 minus 4. That gives me minus 1's whole square is 1. So this is plus 3 minus 4, that is 0. If I'm trying with a 2, so it is 2 square minus 3 into 2 minus 4, that is 4 minus 6 minus 4, that's giving me minus 6 again. If I am trying with a 4, x being 4, so it is 4 square minus 3 into 4 minus 4, so it is 16 minus 12 minus 4, so it is 16 minus 16, that is 0. So now look at these two cases where the 0, I find the value of the polynomial as 0 by replacing x as minus 1 and x as 4. So these are the two when x is minus 1 and 4 are called the 0 of the polynomial. That means what? These are the two values of x where the value of the whole polynomial becomes 0. So 0 of the polynomial refers to that integer wherein the value of the polynomial becomes 0. You might have learnt in previous classes, if there is any linear polynomial given, maybe by 4x plus 3. the 0 of the polynomial, because this is in the form of ax plus b, the 0 is given by the formula minus b by a. So herein, for the example I had taken, it will be minus 3 by 4. This will be the 0 of the linear polynomial. Now we will see the zeros of the polynomials for quadratic, linear and cubic graph. To do so, I will be drawing few short graphs on the Cartesian plane, but without the coordinates. That will help us help me at least quickly explain few graphs at one go. Suppose it is a Cartesian plane and there is this line which I have drawn. This line, equation of this line is given to be y is equal to 2x plus 3. Now there are 2 points of intersection. This point is supposedly given by 0, 3. This is point 3. And this point is given by 0 because y is 0. So it is somewhere, so whatever be its value, maybe it's given as 3 by 2 if I am taking, is as 0. Now looking at this graph, the 0 of the equation of this line is where the y is 0, this one. So the is x here, the 0 of this line will be minus 3 by 2, 0. Minus 3 by 2 actually. That means where the y value is 0 and you consider the x value to be the 0 of this given polynomial. Here it was a line. This is when it is a linear graph. Okay, sorry, graph of a linear polynomial. Now let us consider a graph of a quadratic polynomial. The quadratic polynomial graph, if you draw, will either look like an upward or downward parabola. Like if you draw, it will like this, or it will be like this. This is called the upward parabola and this is called the downward parabola. You get an upward parabola when your a is greater than 0, because quadratic polynomial are of this form. When your a is greater than 0, you get an upward parabola. When a is less than 0, you get a downward parabola. That's the basic information. Now suppose I'm not giving any kind of coordinates. I'm simply wanting you to know how to read the various graphs. The one which first we discussed was of linear polynomial. Now I'm discussing one with the parabola, that is a quadratic polynomial. Suppose this graph, someone draws sketches a parabola. Suppose one of the parabolas look like this. Kindly avoid the figure the way I'm doing because it's a freehand figure and I don't have coordinates actually to join. I'm just trying to make you read, show how to read a parabola. Suppose this is how best I can draw, being a freehand draw parabola. Now if you look at these parabolas, you'll see, suppose this parabola is of x square minus 3x minus 4. There might be various coordinates there. Here you will get coordinate, here you will get coordinate. At this point also, that the lowest point also you'll get coordinates. Maybe this point also will be given by coordinate. But the important thing which I'm wanting you to notice are these 2 points. This point is given by suppose minus 1, 0 and this will be given by some 4, 0. So these are the 2 zeros of the polynomial where the y becomes 0. So minus 1 and 4 are the 2 solutions for the 0 of this given parabola. Now let us take few cases, because all the parabolas will obviously not be of the same form which I have drawn now. I'll just move further to draw few small figures to see. Let us see how various types of graph you might get, and how that, what kind of representation we should be understanding from that graph. Suppose this is a downward parabola drawn. There are 2 points of intersection at where y equals 0. So even if it is an upward form parabola, you'll get the same wherein you have 2 points of intersection. So first I'm concentrating where you get a parabola with 2 points of intersection. Here you also might get one which is like the previous drawing, previous sketch which I had made. Here this is 1 point, here it is 2, here it is 1, and here it is 2. This is the first case wherein you see the parabolas are intersecting the y-axis at 1 and 2, 1 and 2. So there are 2 points of intersection. These points are actually the zeros of this given quadratic polynomial. Now take the second case. In the second case, you might get a parabola and downward parabola which passes only through 1 point on the where y is 0. In both these cases, this is only the 1 point where they are intersecting. So these are herein the solution is only 1 0 of the polynomial, even if it is a quadratic polynomial. Now, so it has got 2 solutions, this has got 2 solutions. It has got only 1 solution. Sorry. And the third case I am taking wherein there is no point of intersection of the parabolas. It is not touching anywhere where y is equal to 0. Okay. So there are no there are no zeros of these two quadratic polynomials, because they are not intersecting at any point. So this has got no 0 in this case. Now if it is a you might also come across figures wherein you have cubic polynomials. So cubic polynomial graph would look like the one I am drawing now. Again, I tell you to avoid the kind of drawing which I am making. Yeah, I got it. Now this, if you see, has got here a point of intersection, and then here the point of intersection. So these will be 2 zeros of the cubic polynomial. Now we will be taking up a couple of questions. Maybe now in the next page I take it up. Let us try to figure out. The question reads as, find the number of zeros of these graphs given. You just have to read the graph and say how many zeros are there, not even the values. I quickly draw 3 Cartesian plane. And then I'll draw the rest of them. The first figure says the graph passes like this. The second shows like this. The third is kind of like this. Okay, so this is, I'm not writing for all of them, though. This will be x dash, and then here it is y dash. There are these points of, this is origin given for all 3 of them. The names remain similar. Here if you see, this is the 1 point where y is 0. So here you will have 1 0 of the polynomial, because the graph intersects the x-axis at one point. Either you say y equals 0, or you understand it at where it is intersecting the x-axis. So it is intersecting x-axis at one point, so it is 1 0. In the second one, there are 2 points of intersection at the x-axis. So it has got 2 zeros. This has got 3 points of intersection, so these has got 3 zeros, and this I am taking up, for this is how you read the possible zeros of the polynomial. In the further sessions, we will be taking up the relations between the zeros and the coefficient of the polynomial. Thank you.